molestery, and we're running the session on sutureless valve and TAVI. So my esteemed co-moderator is going to start us off. I think you all know Chris. He doesn't need an introduction. He's a professor at Northwestern, trained at Texas. Great guy. And he's going to speak on TAVI for AI.
Well, thanks, Tony. Good morning. This is the toughest audience here because I've got to teach to professors of cardiac surgery, yet teach to patient level person. Julie Fernari's here. So you tell me if you could understand this lecture as well. And I think we've got a little bit more time. I probably won't take all 20 minutes here. And my charge was to talk about transcatheter aortic valve implantation for not aortic stenosis, but for aortic regurgitation. I'll talk about three things today. The first is a review for residents and students who may be here about lesions for aortic regurgitation and a rule of thumb that I use for indications for treatment for aortic regurgitation. So I like showing this because it helps me remember. The second is I will talk about TAVI, which is off-label for native AR. And the third, I'll finish with on-label devices for native aortic regurgitation. So for AR review, this is the list of AR etiologies to my side here, so your left, compared to normal aortic valve. And I sort of break it down into a couple things. All the way down to the bottom of the list is unusual things, anatomic defects with associated AR, so VSD and subaortic stenosis. I think all of us have seen this. There's this large group of inflammatory disorders, rheumatic, ankylosing spondylitis, syphilis, Takayasu's. I think all of us have operated on this, radiation disease. Dissection and trauma happens with acute type aortic dissection. Infective endocarditis is not a lesion that's suitable for TAVI in Marfan and connective tissue disorder. But the top three etiologies is what I see the most is a degenerative aneurysm, so the valve gets calcified. They usually get aortic stenosis, but sometimes it gets calcified and restricted, causing aortic regurgitation. Bicuspid is a very common one we see as well. This is a good one for repair. We saw a bunch of lectures from the past couple days. The free margin gets elongated. It causes prolapse and subsequent aortic regurgitation. And the whole group of aneurysms, the biggest cause is hypertension, causing a dilated aorta, dysfunctional aortic regurgitation. Indications for intervention for aortic regurgitation, I take from the two sets of guidelines. And certainly patients who have symptomatic aortic regurgitation have a class 1 indication. LV systolic dysfunction, whether or not you have symptoms, is also a class 1 indication. And the key number here is 50%. You add in not just dysfunction, but LV dilatation. If you factor in that too big of a heart is also a sign of heart failure. And LV ESD, so end systolic dimension of 50, is a very big heart. These are some of the biggest hearts we see is chronic aortic regurgitation. So 50 millimeters is sort of the diameter of the bottom of a Coke can. If the heart can't squeeze smaller than 50 millimeters, that's a really big heart. And the Europeans and Americans give that a class 2A recommendation. So I call this the 50-50 rule of asymptomatic aortic regurgitation. So LVEF of 50%, end systolic diameter of 50 millimeters, so 50-50 rule, that's what I try to remember. This is different from the rule for MR. I can tell you that one later in a different talk. You can also add in LV and diastolic dimension, and if you think, these are really big, 65 and 70 millimeter ventricles. The numbers don't match with Americans and Europeans, so I call this the 50-50, like way too big of a heart rule. And I think that's a nice rule of thumb to remember for asymptomatic aortic regurgitation. So that's a little review for aortic regurgitation. Moving to the topic here, what about TAVI for native aortic regurgitation? Remember, TAVI is meant for aortic stenosis. That's the most common disease we see, aortic stenosis in humans. But can we treat native aortic regurgitation or pure aortic regurgitation with TAVI? And these are commercially available devices in the United States now, the Edwards Sapien 3, the Medtronic Evolute Pro, and recently the Boston Scientific Lotus Edge. These have an FDA approval for aortic stenosis, all risk cohorts, but they're not approved for aortic regurgitation. But can we use it for AR? There's some unique challenges for using these devices for AR. They all have to do with the fact that there is very little calcium to anchor the valve. The calcium prevents valve migration and prevents perivalvular leak. But that hasn't stopped many from doing this procedure. So here are two large multi-center registries looking at TAVI for pure AR, just recently published 2 years ago, 2017. That one's hailing out of Cedars-Sinai. The other one, Sawada, hailing out of Copenhagen. So I sort of think American-led and European-led. The Cedars registry was the largest one, 331. And initial results were bad, very, very bad. So the first group of patients were treated with the original core valve and Sapien XT, so that's the second generation Sapien valve, in a group of patients with an STS score of about 7, so these are high risk, inoperable patients. Look at these outcomes, they're terrible. So 13% 30-day mortality in the Jung study, 22% 30-day mortality. So you look back to the STS prom, that's worse than what you would get with just operating on them. So these are bad, bad outcomes. I'll highlight a couple other things. The need for a second valve because of the valve migration was very high, 24%, 25%. And resulting hemodynamic outcome was similarly poor. A quarter of them got moderate or severe AR. Now they continue to follow patients, now with patients with the newest generation valves, so Evolute, Sapien 3, and a lot of the transapical Jena valves. And the outcomes come down to something that's more reasonable. So STS prom and observed mortality are pretty close here, but still at 8% 30-day mortality, this is not what we would expect for TAVI for aortic stenosis, so still a little bit high. The moderate and severe AR is back down to something that is acceptable for patients, but keep an eye on for the need of second valves. Still about 10%. So 1 in 10 patients would get a second valve implanted. So this is one of our cases. I think this patient, I think it's fair to call high risk, 70-year-old patient, symptomatic, previous mantle radiation. These are pretty bad for Hodgkin's lymphoma, severe AR. And 3-vessel coronary heart disease. So radiation, heart disease, radiation is the gift that keeps giving. So the patient had valvular heart disease as well as, it's not going to play, as well as coronary artery disease. Patient was very, very frail. So we felt okay, a little bit okay about this. This is pure AR, but you can see a hint of sclerosis, maybe some calcium on the aortic valves, maybe something to anchor to. So our strategy was to pick a fairly large valve. So typically we like to oversize somewhere between 10%. Here we're trying to oversize closer to 20%. And with that little bit of sclerosis in the valve, we got a pretty good result here. And we're sure to keep that balloon way, way down to see if we can make that valve implant without moving. And postoperatively, got pretty acceptable results, but mild aortic regurgitation. I can't say that this has been the case for all of them. We've had a bunch of LVAD pump aortic regurgitation. So that's another group of patients that large group of patients get treated with this, and we've definitely had to put a second valve in. My heart failure cardiac surgeon refused to give me any of those videos because it's bad advertising for us. But we do need TAVI for on-label TAVI for this disease, and there are two devices available in the world. The Jena valve is the German valve, and perhaps some people in the audience already have more experience than us. There are 14 sites in a single-arm feasibility trial looking to enroll about 70 patients. And that's a German valve. The other valve is the J valve, and it's made in China. So the J is a little bit misleading. It's not a Japanese valve, it's a Chinese valve. And that's available in the United States just in compassionate use. And they're planning a US trial. And the feature from these valves are these little winglets here that are designed to seat into the sinuses. So let's see if we could play this. It's not gonna go. Okay. That's all right, I could see it on my screen. Okay. Now the outcomes for this have been tracked, and the procedural safety is probably about the same, mortality bar all the way down to the bottom, looking at J valve and Jena valve versus other, about the same. But you see there's a higher success rate with this, this valve, and it's now going to be available in a transfemoral platform, so a specially designed device for native aortic regurgitation. I think it'll be useful for a group of patients, particularly our pump AR patients. So in conclusion, don't forget the 50-52 big rule for asymptomatic AR, but commercially available TAVR valves, the 3 valves that you know for aortic stenosis, are available. They're off-label, though, for pure aortic regurgitation. And it seems that off-label TAVI is a reasonable option for, I think, higher risk patients. I wouldn't offer this for patients who can have an operation, so I would not offer it for patients who are intermediate or low risk, in particular if they can get a valve repair. But they're still associated with the need for a second valve implantation. So if you decide to go forward with this procedure, you got to be ready, 1 in 10 of cases, that you're going to need a second valve to place. The Jena valve and J valve are designed specifically for aortic regurgitation and very likely will have better procedural success. Thank you for your attention.
Thanks, Chris. Questions? I have a question for you. I mean, with such a good operation for AI right now, with what I like to call the Rankin ring, the aortic ring, why in an intermediate risk patient with an average STS risk of 6.2% would we want to put a valve in that has a procedural failure rate upwards of 20%? Because procedural failure is defined as more than 2 valves, continuing AI as opposed to AS, or inability to place the valve, which we didn't see in those studies.
Probably never, yeah. And that's why that there's not a lot of money being placed in TAVI valves for aortic regurgitation. It's already such a small market, and then you subsegment that to only patients who are high risk. The LVAD guys love it because that's a good solution for pump AR. They don't want to go back in and give a patient another sternotomy before their planned transplant. So it's a very, very small market.
Anyone?
Julie, do you have any questions?
Scott, what's the mortality rate for doing a ring repair? So 3 out of 700, so 0.5, 0.4. Yeah, I think it's such an elegant solution that that probably the STS risk based on aortic valve replacement is probably higher than the risk based on repair, right?
Okay, I'd like to introduce my co-moderator, Tony Fernari. And this is an exciting talk because he's already rocked 2 continents with his talk. First at EX, then recently at STS. So Asia will be the 3rd continent to see this hidden data from the partner trial.
Thanks, Chris. Good morning, everybody. These are my disclosures. Actually, the first one is a negative disclosure. It's a reverse conflict of interest. So, as surgeons, we accept several things. Number one, we accept TAVI is here to stay. You know, and there's truth in data, and we know in the end science will prevail. That's why we like to look at data. So we know TAVI is here to stay. It's been better than we've imagined in all risk populations, and it's radically changed our specialty. And it's done this because we believe that we can't ignore the data, the science and the outcomes. So we've accepted those data, those science and the outcomes. And those data for Partner 1A were presented to us in 2 cornerstone publications in New England Journal of Medicine in 2011 and in 2012. And these cornerstone publications, which were the basis for all subsequent TAVR, whether it was with the Medtronic valve or with the core valve or the SAPIEN valve, told us that TAVI, in high-risk patients, TAVI was non-inferior to surgical aortic valve replacement through 3 years in terms of mortality, symptom improvement, valve hemodynamics, and MACE. Pretty much a slam dunk. And those data, after they were published in the New England Journal in May of 2012, were presented 1 month later on the June 13th, 2012 Circulatory System Devices panel to the FDA. And the device was approved as safe by a vote of 10-2, efficacious 12-0, and benefits outweigh the risks 11-0 with 1 person abstaining. Now, if it was such a slam dunk, why were there 2 people who voted against it and 1 who abstained? It's interesting, Lund wrote in the Cochrane database a meta-analysis, did a meta-analysis of 75 papers. He compared sponsored to unsponsored studies. And compared with non-industry sponsored studies, industry-sponsored studies more often had significantly more favorable results, significantly more favorable conclusions, and less agreement between the actual results and what they concluded. There was discordance between the results and the conclusions. And his conclusion was the analysis suggests there's evidence of an industry bias that can't be explained by standard risk of bias assessments. So we wondered, based on those 2 things, did that exist here? So we looked at all the available information from the June 13th, 2012 devices panel, which is available online at that address below. And by the way, this is the only information that's publicly available. No subsequent trial has any information available. And specifically also looked at the FDA executive summary of that meeting. And based on that, we have determined that clinicians and some study investigators, maybe even some study investigators, were not told the whole truth about Partner 1A. We weren't told the whole truth. This assured clinical acceptance as it was rolled out, and it likely affected future patient selection and outcomes. But because there's truth in data, and we can't ignore the science, the data, and the outcomes, I give you what I call eyes wide shut, the hidden data from Partner 1A. Chapter 1, if I only had a brain. We were told that TAVI was, in terms of stroke, TAVI was the same as surgery. There was no difference, no statistical difference over 3 years in the stroke rate for TAVI versus surgery. And this is true if you look at the rate over the time. They used the log rank test with a p-value of 0.5. Well, log rank test looks at the rate of stroke over time. And notice the y-axis. It goes all the way up to 70, so you really can't see much of a difference. But let me give these numbers to you in a much more easy way to understand. In the as-treated group for all TAVI, there was 2 times higher TAVR at every single point in time with TAVI than there was with surgical aortic valve replacement. These numbers were never published. Now, this wasn't completely held from the public because Craig Miller found this out and published it with actually a better y-axis, a more appropriate y-axis, in 2012, later that year. In the transfemoral stratum, there's 3 times higher stroke rate with TAVI than there was with surgical aortic valve replacement. Chapter 2, if I only had a heart. Now, we all know that TAVI has much more aortic insufficiency than the surgical AVR. We know it's significant at all time points. But the way the data were presented were like this, in these sort of Wizard of Oz rainbow-colored charts, and it's really hard to discern the difference between the two. So let me show you what the difference looks like in a very easy way to understand. In terms of mild, moderate, or severe total aortic regurgitation, TAVI was at least 3 times higher than SAVR on every single time point, with insufficiency rates of 62, 56, and 56 out to 2 years. Now, we know that. It's happened. It's not a big deal. Why it's important is because any amount of AI, whether it's total AI shown here or paravalvular AI shown here, even mild AI, significantly impairs survival. We were told that. What we were not told is that in the surgical population, aortic insufficiency does not impair survival. There is no difference in survival if you have no AI versus if you have severe AI in the surgery population. Now that tells me one of 3 things. Either the surgical AI was overestimated, the TAVI AI was underestimated, or these are 2 completely different operations. And it may be some of each. In addition to this, and probably more importantly, we were never told that surgical aortic valve replacement has better reverse remodeling than TAVI, and it's significant. There's an 84% better left ventricular end diastolic volume reduction after surgical AVR at 1 year, and a 53% better LV mass regression with surgical AVR. You won't find that data anywhere except within the 1,200 pages of the FDA data. Chapter 3. TAVI is not non-inferior to all surgical aortic valve replacement. I'm going to stop there for a minute. I want you to read that. TAVI is not non-inferior to all SAVR. So we know in the Partner 1A trial that TAVI was found to be non-inferior to surgical AVR. And non-inferiority is defined as, I don't know what's happening there. Non-inferiority is defined as the difference in the lower confidence interval between these 2 groups. So if you look at the difference in survival at 1 year, the 95% lower confidence interval, if that lower confidence interval was more positive than minus 7.5, it was felt to be non-inferior. If the lower confidence interval was less than, more negative than minus 7.5, it would have been inferior. That was the whole group. What we weren't told was that in males, in the 400 male patients in this study, which is a significant number and is well powered, the lower confidence interval was minus 10.8, way lower than the predefined accepted level for non-inferiority. So in males, TAVI is inferior to surgical aortic valve replacement. Now this concerned the FDA so much that in just the 52-page executive summary, they mention it no less than 3 times in their comments. Now, although I highlighted this because I was trying to remember what was in here, I did not underline that lower line, and I did not capitalize the word not. The FDA did. Non-inferiority was not met in the male stratum. In addition, there's 4 to 5 pages of discussion during the panel discussion about this phenomenon, and they implored Edwards to look into it further. It was never done. Now, another person did it in a meta-analysis. This is O'Connor, wrote a meta-analysis in 2015 of 11,000 TAVI patients. And he found that female sex is an independent predictor of late survival after TAVI. Well, because female sex and male sex are dichotomous variables, the converse is also true. And this was written in a positive form, but this really says is Male sex is an independent predictor of early death after TAVI. So this did not come from the partner trial. This came from a meta-analysis. And O'Connor says this should be taken into account during patient selection for this procedure. So even though it was known since 2012, we've not been able to take that into account because nobody's read those 1,200 pages, very few. Chapter 4, shifty nomenclature hides the valve implant comparison. What do I mean by shifty nomenclature? I feel that the nomenclature was shifted. You know, intent to treat group means intent to treat, and that means that there's a mutual intent to treat and be treated. It turns out that wasn't true in this study. In the as treated group, in which there was a mutual intent to treat and be treated, it just means that anesthesia was begun. And we were not told that there were crossovers. And in fact, the as treated group does not mean the valve was implanted. It does not mean the valve was implanted, but the true valve implant comparison analysis was never done. Now let me show you what I mean by this. So in the TAVI arm, there are 348 patients who are randomized to TAVI. 1% dropped out, and leaving us with 344 TAVI patients. In those 344 TAVI patients, 18 patients did not have an implant. 18. But because they were treating the as treated arm, they were analyzing it as an intent to treat arm, they left them in the as treated arm. And in fact, 11 of those 18 patients went on to have surgical aortic valve replacement, and in those 11 patients at 1 year, only one died for a 9% overall mortality. That 9% mortality served to improve the overall mortality of the TAVI AT group, which was reported at 24%. What about the surgical arm? There are 351 patients randomized to surgery. A full 11%, 38 patients, dropped out of the study after being randomized. So there was not a mutual intent to treat these 38 patients. The majority of them, at least 28 of them or more, were basically going into the study like a lottery. If I get it, I do, but I don't really want surgery. Of the 313 patients who actually wanted to be treated where there was a mutual intent to treat, there was actually 2 patients who didn't have an implant and 1 crossed over to TAVI. In the implant group of 311 patients, there were 40 patients who had concomitant operations. And this is not reported anywhere in any of the partner study data in the New England Journal papers. In those 40 patients had significantly risky operations. Half of them had coronary bypass, there were double valves, there were aortic root replacements, there were arch replacements, there were endarterectomies. This is high-risk stuff. And because it's high-risk stuff, in those 40 patients, there was a 42% mortality. 42%, which served to significantly raise the mortality of the overall as-treated group. So I'd put forth to you that this was not an apples-to-apples comparison of TAVI versus isolated AVR, which is what I was mentioning the other day during Chris's talk. So we don't have an isolated valve-to-valve comparison, isolated AVR versus TAVI, but we can do it with the data now. So let's do it. So here's the TAVI group. We remove the crossovers, and we take out the no implants. It leaves us through 326 valve implant TAVIs. We add back the 1 patient who crossed over to TAVI from the surgical arm. We get an actual implant mortality of 1 year at 24.5%. What about the surgical arm? In the surgical arm, we moved the 2 crossovers that we just put in the other group. And because we want an apples-to-apples comparison, we should do, and they should have done, they should have excluded the concomitant operations. That leaves us with 271 isolated surgical aortic valve replacement patients. We then add back the 11 patients who crossed over from the TAVI arm and their 1 mortality for 282, and the overall isolated surgical aortic valve mortality was 21.6%. So now it's easy. The difference between 21.6% and 24% mortality at 1 year is a 1-year difference in survival of minus 2.83, with a lower 95% confidence interval of minus 0.843, which is more negative than the predefined non-inferiority margin of minus 7.5. Therefore, non-inferiority is not met in the apples-to-apples comparison of Partner 1A of surgical aortic valve replacement versus TAVI. And in the valve implant group, which was never analyzed, TAVI is not non-inferior to surgical aortic valve replacement, i.e. surgical aortic valve is superior to TAVI. So, in summary, high-risk TAVI is inferior to isolated surgical aortic valve replacement in the valve implant group in high-risk patients. It was known to be inferior to SAVR in all males since 2012. There's a 2 to 3 times higher stroke rate at all time points versus surgical AVR in the high-risk group. And there's significantly less reverse remodeling with TAVI than there is with surgical AVR. One of the points that we've looked at for 30 years in the surgery population is reverse remodeling and why AVR is so important for aortic stenosis. And finally, AI does not affect surgical AVR survival. We were told none of this in the 2 cornerstone publications, and it hasn't emerged in any publication from the partner trial ever since. More than that, and more distressing than that, in the paper that came out just 1 month before the FDA trial, we were told crossovers between the treatment groups were not permitted, which is obviously not true when you look at the FDA data. So you have to believe I can only conclude the following, and we can discuss this. My conclusion and our conclusion is that the medical industrial complex, and I mean the entire medical industrial complex, I don't mean Edwards, I mean the medical industrial complex, that is physicians who are doing trials combined with industry who's doing industry trials, having invested billions of dollars into the development of TAVI, wanted to ensure regulatory and clinical approval, which will result in economic success and return on their investment. That makes sense. I understand why they would want to do that. However, in that quest and to that end, somewhere along the way, they've withheld important clinical data, which has impaired the ability of the medical community at large to fully evaluate the comparable effectiveness of TAVI to isolated SAVR and its impact on specific patient population, like males, in our selection. And that in turn has irreparably impaired our ability to rationally and safely deploy this technology to the appropriate patient populations without concomitantly, unwillingly, and even unknowingly doing harm. So the truth is out there. The truth exists on the FDA database. We haven't been told the truth until now, but I feel that surgeons deserve to know the truth, patients deserve to know the truth, and cardiologists need to know the truth. Thanks very much.
Thanks, Tony. I've had some time to think about your talk, and I think it's really important for people to understand why the intention to treat analysis was unreliable. Therefore, you had to go to an as-treated group. So there was an ITT analysis that was done, and that was what was reported. But why is that unreliable for this trial?
Yeah, it's unreliable for this trial because there's such a high, there's a disparate dropout between the two arms. When there's 11% dropout on one side of an intent to treat arm and a 1% dropout on the other side, it fully invalidates the trial as a randomized trial. And Nick Fremantle spoke about this at EACTS, and he spoke about it at the STS. And for that reason, and also the reason that in the AT group there were less dropouts, he believed, and I believe, that the AT group that's been reported as treated should have been the intent to treat group because there's a mutual intent to treat. Because when you randomize, you're trying to randomize 1-to-1, and you have 11%, 38 people drop out before entering the study, it totally invalidates your randomization.
I'll point out one thing. I think a lot of us enrolled in the TAVI trials, and dropouts were a problem. And I fully remember seeing patients in the clinic, and their intention was to randomize in TAVI, and if they randomize in the surgery, just to drop out of the trial. And it's like, no, we can't do that. That's going to totally kill our trial. So there was one center that that overcame that, and what I thought was brilliant. We should have done it from the beginning. They didn't tell the patient until they're in the operating room or procedural room whether or not they're going to get an AVR or TAVI. So they'd randomize the patient after anesthesia. So you had a captive patient. So I think that was the only way to overcome this problem with intention to treat.
Yeah, it's a really important thing, Chris. There was actually in Nick Fremantle's talk, there are actually 4 centers within the Partner 1A trial who had very disparate TAVI versus surgery arms, like 15% more TAVI than surgery, and they felt that there was some cherry picking going on. Hi, Hartzell.
Tony, congratulations. Great talk and a very thoughtful analysis. Could you drill down just a little bit more on the understanding that the surgeons in the trial had about these data? And when you present that to us, this is a friendly audience. What happens when you present this to the surgeons in the leadership of the trials?
It's really interesting. I will tell you there is a dichotomous response, Hartzell. I have come to find out since I made the presentation last week at STS. Let me tell you the process that went on. Edwards took the data on a computer, all the data, and handed it to the executive committee of the writing for the partner trial. And that was comprised of, I think, 6 people, 3 cardiologists and 3 surgeons. They decided what to publish. The executive committee did. And they started it on the data and did the publications. The paper was, so those 6 ostensibly knew all the data. The papers were then written and sent out to the various trialists, Chris amongst them. Chris was on the second 2012 paper. Craig Miller, everyone else, who were basically given the opportunity to read the papers and sign off, and they did. So my understanding is that some people knew all the data, but not everyone. Certainly, Marty Leon and Mike Mack knew all the data. I believe everybody who was at the FDA panel meeting knew the data, and we can identify those people by saying they were there. And the discussion that went back and forth about males was there. There was a discussion about concomitant surgery by the FDA and how it biased the results against surgery. So I think the people at the panel, Julie Swain, everyone else knew that. But I think the other trial investigators, Chris, Craig Miller, everyone else, really was unaware of this going on. That's why I said we clinicians who weren't in the trial, and even some study investigators didn't know. But I've come to learn that Edwards, I think, did the right thing. In fact, they did the right thing. They took the data and they handed it to the writing committee and said, here you go, here's the data, write it up. Now, having said that, there was at least one Edwards employee on the authorship list. So they could have helped direct it a little bit. And I don't want to point the finger at any one person. Here's why I think these data are important, because people say to me, well, so what? It's a sapien valve. It was the first generation. So we're well beyond that now. Why does it matter? To what end? This is to what end? Number one, I think we did a disservice to patients between 2012 and about 2016, not knowing about the male not inferiority. And I think some males may have received an inferior procedure unknowingly. I have a big ethical problem with that. Number two, and probably more importantly, this is the only data. Edwards they jumped through more than hoops. They went to the moon and back collecting these data. This is probably the biggest randomized surgery trial ever. It's been studied up and down, left and right. They went to all this expense and all this time to collect these data and turn it into the FDA, which were then made public. As you know, I know Hartzell knows this, and I know that Scott knows it. Once a device is approved and it's called a widget A, subsequent devices that come along that are called widget A or that are called TAVI do not have to go through that public scrutiny. They don't have to sit in front of a public circulatory devices panel and vet their data. They just have to prove safety. And so we don't have a view into Partner 2, Partner 3, Evolute 1, Evolute 2. We have no idea what went on in those trials, what the dropout rates were, what the crossover rates were. Were the crossovers appropriately applied? Were the concomitant surgeries appropriately removed so we're comparing apples to apples? And based on Partner 1, I can guarantee you it was not done in Partner 2 and 3. And based on partner 1, I could pretty much guess it wasn't done in Evolute 1 and 2 either. So to what end? I think this is a call. It's my call to reopen the data and reanalyze every single piece of data based on an apples-to-apples isolated AVR comparison to TAVI in each of those 5 studies. And we intend to publish this. The paper is mostly written. I'm going to give the New England Journal the opportunity to do it. I think they'll reject it just because, I don't know, but we will publish this, and it will be there. So this is, to me, it's a call to action to re-examine what's out there so that we know and patients know, and we're making appropriate decisions for patients. That's a long answer to a really short question. I hope it was answered.
Tony, can you tell everyone who's running your stats? For this is 1,200 pages and lots of numbers. Who's running the stats for you?
There's a guy named Gary Grunkemeyer, who I think most people in this room might know. I work with Gary on a daily basis. Gary's probably one of the 2 foremost cardiac surgery biostatisticians in the world. And it's Gary and his team. Thanks very much, guys.
It's gotten better. Our last speaker today is Dr. Hiro Ninami, and he's going to be speaking on sutureless aortic valves.
Good morning, everybody. Maybe some of the attendants here is more experienced in sutureless valve, but we just started using this device in Japan, so I'm going to talk about this. These are my disclosures. So the Intuity is it's not pure sutureless. It's called a rapid deployment valve, and the first valve is a pure sutureless valve, as you know. So this slide, it's in the United States already the TAVR is overcome to this surgical AVR in the year 2015, and my country in Japan is getting almost the same situation, and Europe is far away, and especially in Germany, the number of the TAVR is, and the surgical AVR is actually decreasing. That's what I heard. So why this now? I mean, this device, because the TAVR era. Are these devices really innovative? I'm not sure, but I believe this device is good for certain certain group of patients. So I'm going to talk about the Intuity. So some of you, the attendants, doesn't know about this the device. So I'm just briefly explain and introduce this device. The top part is completely same as the Magna is. So we know the durability of this device. The bottom part is like a Sapien. So I will just briefly show how to do the animation of this implanting this device. So the incision is exactly same as the conventional way of the aortotomy, and putting 3 stitches onto the nadir. I normally use just a simple single stitch. So, and then put down onto the annulus and snare it. And then just inflate. So this is almost the same as a Sapien. So of course this is Edwards device. So the concept is a very quick implantation compared to this conventional way. And we need to tie down all 3 points. Okay? This is Intuity. So this paper is published in the Journal of Thoracic Cardiovascular Surgery in 2017, the TRANSFORM study. So this trial evaluated the performance of the Intuity in patients with severe AS and was a prospective non-randomized trial, multi-center in US. So the primary safety point is the thromboembolism bleeding is reasonable. However, this is a problem. paravalvular leakage more than moderate is 1.6%. And also the new pacemaker implantation rate was actually 11.9%, which is quite high. And 73.3% of the patients pre-existing the complete right bundle branch block. The hemodynamics is quite reasonable because they use the Magna valve. The secondary endpoint is almost quite acceptable compared to the conventional technique. So aortic cross-clamp time for first sternotomy, 49 minutes, mini sternotomy, 62 minutes, and right thoracotomy, 66 minutes, which is a little bit shorter than our conventional way. If we compare to the STS database, those the groups are significantly shorter cross-clamp time. So they concluded that Intuitive performed effectively in the North American trial. It may lead to a relative reduction in aortic cross-clamp time and the cardiopulmonary bypass time and excellent hemodynamic performance. However, has some the pacemaker rate. The Percival, this is a pure sutureless valve. So this is more like a quad valve. It's a self-expanding using the nitro stent frame. The major difference between this one and the conventional way is the aorta is quite, you have to open the aorta quite higher. Otherwise, because of the stent frame is quite high. But otherwise, the technique is exactly the same as the conventional way, removing all the calcium on the aortic annulus. And also, this valve, the sizing is quite important. Never do the oversizing using this valve. That's from my experience. And they say this is not a crimping. This is called a collapsing. So holding the valve, not the crimping, not destroying the fiber of the tissue. And then putting the 3 guiding sutures onto the nadia. So this is exactly the same as the Intuitive valve. However, you don't need time after all. So just remove all the guiding sutures. So deployment is just releasing the sheath and post-dilatation for 30 seconds. So that's it. So this is really easy to implant. So one of the major concerns is the durability of this valve, because Intuitive is they use the Magna Ease, but this valve is really new valve, and they need to do the collapse. So again, it's similar to the crimping, but they say it's so different. So there's a paper showing that the collapsing. So they say collapse and the ballooning does not affect the structure integrity of the collagen. So which it doesn't affect for the long-term durability. So there's some papers to show the mid-term and long-term durability of this the device. So over 700 patients, this is a European study for 5 years. So they concluded that there are no valve migration, structural valve deterioration, or valve thrombus in the follow-up. So another paper, actually this is presented last year at the ASCVTS from Belgian experience, 11 years in about 470 cases, and no SVD. So which means they are quite promising of this device, but we have to see for more long-term durability. So the Intuitive, the Percival, which is better? There's one study from Europe, from Italy, I think, the sutures versus rapid deployment. So these they implanted 911 patients in 18 institutions, and the propensity score analysis was performed, and 117 patients each group. So their conclusion is intuitive valve and the perceval valve provide good and similar early clinical and hemodynamic outcomes. However, perceval valve implantation requires shorter cross-clamp time and the cardiopulmonary bypass time, whereas intuitive valve implantation provides a lower pressure gradient. So in Japan, those valves are already reimbursed about 1 year ago. And my institution, we started using in the middle of last year. So we don't have so much experience. And those devices are only so for the limited center we can use. So my center, we just started and small experience. Intuitive valve, we implanted 20 cases and the perceval 34 cases. So the patient characteristic is almost similar, but the difference is the body surface area. Perceval is smaller and higher risk factors. Preoperative cardiac rhythm is the same. Pre-op echo data is identical in two groups. Intraoperative data show that, concomitant surgery is about 50%. So we feel that this valve is good to use for the case of the concomitant surgery because the less aortic cross-clamp time. So in the intuitive group, about 55% concomitant surgery and the perceval valve at 41% concomitant. I compare to the isolated AVR, the cross-clamp time and the cardiopulmonary bypass time. So it's kind of learning curve, so it's quite long. Intuitive 50 minutes and the perceval 53 minutes for the isolated AVR. But after like 5-10 cases, so now the perceval is shortest cross-clamp time is 30 minutes and the intuitive almost 31 minutes. So it is really quick and shorter cross-clamp time you can have. So postoperative data between two groups. Trivial paravalvular is much higher in the intuitive group. The perceval, we are lucky, but we don't have any leakage. And the pacemaker implantation, they say about 10%. So intuitive has 10% pacemaker rate, but the perceval, we don't have any pacemaker implantation. So then the intuitive group, we use those two cases pre-existing complete right bundle branch block. I think that's those cases we shouldn't use the intuitive to avoid the pacemaker implantation. Postoperative hemodynamics comparison. As you know, that the perceval is not like a 1921. There is a small, medium, large, and extra large. So I can compare to the 19 valve and the small size of the perceval. So, and the 21 millimeter size of the valve of the intuitive and the medium size of the perceval. So no difference between two groups. So what kind of indication to use these devices? Of course, these are indicated only for the severe aortic stenosis. So one of the indications maybe this group. Old patient, obese patient, patient who needs a less traumatic procedure. But these are good candidates maybe for the TAVR. How about diabetic patient with low EF? There's a paper to show that this group of patients, shorter cross-clamp time is better for the postoperative mortality and the morbidity. But this group of patients is also a good candidate for the TAVR. So I think that this device is good for this kind of group. Concomitant surgery, small aortic annulus, and very calcified aortic group. We do have the hemodialysis patients a lot in the country, and about 20% of patients on hemodialysis in the severe aortic stenosis patients. And those groups are not good candidates for the, it's contraindicated for TAVR. So I'm going to show you some of the examples that calcify the aortic root. So pulse in aorta, like this. So this case is quite difficult to, you may replace the ascending aorta, but that's a big surgery. But as you see, some of the space behind the aorta is free from the calcium. So I use this case pulsable. So I cut the surgeon side, not to the left coronary sinus. So it is not so difficult. So I don't touch any calcium, and then put the pulsable in. So this is a good candidate to use this device, I think. And another example is small aortic annulus. This patient, 80 years old female, mitral stenosis and the aortic valve stenosis. You see the body surface is 1.1. The weight is less than 30 kilograms. Aortic annulus is 17. So, of course, you can do the aortic root enlargement, but 80 years, very small lady, very fragile, and two valve replacement. And the echo showed only 17. So what I did was I put the 25 size the peak valve to the mitral position, and the small size with a Percival, and this is fully expanded. So this is the one of the good candidate to use this kind of valve. So in summary, so the sutures and the rapid deployment valve can be a promising alternative to biological aortic valve replacement. The sutures and the rapid deployment valve may have advantages over the conventional biological valves in patients who require technically challenging procedures. Thank you very much for your attention.
Thanks, Hiro. There's a lot of interest in the new technology here. We enrolled in the Transform trial, and there was a couple of contraindications to the trial, which I wanted to get your opinion on. We were not allowed to enroll infective endocarditis, active endocarditis, and we weren't allowed to enroll pure AR or AS with aneurysm. Do you think the sutureless rapid deployment valves can be used in active endocarditis in patients with pure AR?
I don't think it's good for the active endocarditis because so much the like a stent frame and or those materials not good for the endocarditis. But I think another one is PAR. I think that one, the Intuity, maybe it's still good for the AI. But you can have not only 3 stitches. Maybe we can put 4 or 5 stitches. Then I think we can avoid the migration and the paravalvular leakage. So that is different from the TAVR, I think.
Hiroshi, this is a beautiful talk. You know, these valves came out to reduce clamp time, reduce bypass time, in hopes that that would improve outcomes in some way, shape, or form. We did, using our database prior to Intuity coming out, we did an analysis for Edwards, looking at what point in cross-clamp time outcomes started to rise. And we found that it was about 120 minutes of cross-clamp time. So my question is, you know, we were reducing cross-clamp time in your study from like 69 minutes to 48 or 50 minutes. Did you see or do any of the studies show an improvement in any other outcome other than operative time, cross-clamp time, bypass time? I mean, something that makes a real difference to the patients. Has that been shown yet in any propensity matched analysis?
I don't have any data, but some of the data show that from Europe, I think that some certain group of patients like a diabetic and low ejection fraction, the patient, those patients, the reduction of the aortic clamp time really beneficial, and less the mortality and not mortality, morbidity that they showed. So there are some advantages. But I don't think that's this valve's advantage, not only that, but also especially the perceval, the small aortic annulus. Like in the Asian society, still we use the 19 and 21, about 70%, which is quite different from the Western countries. So this valve is really advantageous to use. And 17, maybe that was contraindicated, but what I did was I inflated the balloon on not like a five atom. I use like a 7, 8 atom for 1 minute. So it's not a good way to do it, but I feel that much better using the aortic root enlargement technique, and this worked well without any heart block. So this is one of the indication to use this device. So not only the saving the time of the aortic cross clamp time.
Presentation very much. I've been involved with this valve for a long time. And I think I just wanted to reiterate your point about the small aortic root. I have not done a root enlargement since we've been using the Perceval valve. And we basically find that the hemodynamics of it are excellent, even in the smaller sizes. And in fact, in our study, you're much more likely to get a higher gradient. And what I call a higher gradient is a mean gradient over 10. Almost all our gradients are in the 5 to 7 mark if you use a valve that's too large. So one of the problems with this type of valve is, in fact, the leaflets don't open fully if you put in too big a valve. The second point I'd like to make is I agree with you entirely about the right bundle branch block. And in our series, which is under review at the moment, right bundle branch block is the strongest predictor of requirement of a permanent pacemaker. Interesting point. And now, if you have a patient with a pre-existing right bundle, would you not use a rapid deployment / sutureless valve?
I think we use this device for also the patient with the right bundle branch block and the Perceval group and the no block. So I think the Perceval is safer in terms of the heart block. That's we don't have so much the experience so far, but that's my impression, because that's scarred for the Intuity, the valve. That's really hitting the membrane septum, but the Perceval doesn't have that kind of high scar, so I feel that's safer. And your comment is great, and the Italian study in comparison between the Perceval and the Intuity, the hemodynamically, they said the Intuity is better. But that's very strange, because the Intuity is just the magna. But the Perceval is, I think, the kind of the stentless valve. So supposedly, Perceval should have the better performance. But why they didn't have the Intuity performance better? Because they oversize too much. So we learned lots about those studies, so we never do the oversizing. And then we can have a good hemodynamics data. So that's why we didn't have any difference between two groups. Thank you very much.
All right, thank you guys for participating in the morning session. We'll take a break, and awesome. Hiroshi, that was
very much.
awesome. Thank you guys.